Hello again, my name is George Flew and I'm the developer of the 3DUtility toolbox. This video is the third in a series of videos demonstrating some of its many features. The toolbox itself consists of over 1,000 AutoCAD drawing blocks, including switches, connectors, structures, etc., and over a dozen major apps written in AutoCAD VBA and AutoLisp. I originally developed the toolbox in AutoCAD 2016. However, the application I'm using here is BricsCAD, which was developed by a firm called BricsCAD, and it has been around since 2002. You can get more information at bricscad.com. I'm sure that we've got a link showing up here now that you could use. I've been using BricsCAD for several months now and found it to be an excellent substitute for AutoCAD. The command set and structure is identical to AutoCAD, which makes the learning curve for an AutoCAD user quite short. And before I go any further, I just want to say that I in no way represent BricsCAD other than as a user. Alright, so let's get back to our substation design. Let's review the substation configuration. We've got two incoming 161 lines coming into these two bays. It comes in dead ends, comes through a V-switch to a SF6 breaker, a circuit switcher, an isolating 161 kV isolating switch, cross bus, support structure, and then to the 161 to 12 kV 182430 transformer, then a 12 kV isolating switch, a meter structure, another support structure with a station service transformer. Then we have three outgoing breaker bays. In our first two videos, we installed the equipment and structures, and then came back in the second video and put in the bus and the jumpers. In this video, we're going to complete the load side of the station and demonstrate a few extra features that I feel are important. So first, let's go up here to our look from tool, and let's go to our orthogonal view. And as we zoom in here, we see that one of the things we're missing here is this structure, and this structure is a metering structure, and it's actually, if you notice, this is something a little new. It's an assembly. It's a structure assembly metering, three-phase, 12 kV. Pardon me, there, 12 kV, 17 foot. So assembly is a new concept here that we're introducing. Let's go over to our structures, and let's just scroll down, and we can find here our metering assembly. Here it is: assembly, structure, metering, 3-pole, 12 kV, 17 foot. So you see that down here. Now I can go up here and right click on this and open a copy of it, and here's our assembly, which is made up of a number of blocks. First is the structure block itself, and then on the structure we've got three CTs that are each a block. We've got three VTs over here. We've got some conduit, and then some conduits, which are blocks. Comes down to a meter cabinet, which is a block. All this conduit is conduit. Got some more conductor. This is some number 4 grounding conductor for those VTs. So this is a block that has nested within it other blocks, and that's important to understand that. So this is a block, and these are nested one block deep. The 3DUtility toolbox bill of material routine will drill down into these assemblies one layer and find the blocks that are nested one layer deep, and count them. Now you can't, if you try to nest a block, nest assembly within an assembly, then all of the blocks that are in the other assembly, which would then be nested 3 deep, would not be found. So If you find it necessary to do that, then if you insert that assembly, you would need to explode it so that they would be individual blocks and assemblies. Let me here just give a quick example. If you for some reason felt like you were insert these this switch structure, the switch structure, meter structure, and then this support structure. If these are normally part of every substation, then you could create a block of these, but then this assembly would get lost in the bill of materials unless you inserted that and then exploded it. And then they would become these same individual items you're seeing here. So you just need to be careful and understand exactly how that works. And certainly if you have a question, I'd be glad to address that in more detail. So we're going to come in here and insert this. So we don't need the node. We want the intersection again. Let me move this back up, give us as much room as we can. Do an insert, come down here, and it finds it, click, and now we have it. So that's that. Now let's go back up to our plan view. So now let's go look at these low side structures. Let's start over here with this one. This structure is, if you can see here, is an assembly. It's a structure breaker overhead T1101. So let's just go up here and look at that. T1101 is a full bay. Again, as we were looking, it's got your bus over bus, your overhead exit, and then we pair that up with this T1201, which is sitting here, which has, if you notice, it's not a full bay. It's missing the column on this end, and then this horizontal structure, and all the insulators and connectors. That's so that we don't duplicate these when we add in additional bays. So let's come over here. So we're ready to insert our new bay in here, but I'm going to pull a little switcheroo on you here. Okay, this is an overhead, and it's got this bus over bus. So we're going to go change to an option that has, here's an underground option, but it's the same bus over bus. We're going to change to an underground exit that has our main and transfer bus on opposite sides of the structure, so they're not above each other, which makes maintenance much easier. It takes a little more real estate, but that's okay. So we're going to, this is our assembly structure breaker underground T21, and that T21 really just changes it from this T11, which we just need to keep these names unique. T21, 01, 12 kV or 15 kV class is what we're saying. So again, we're going to use intersection. We're going to do an insert. We're going to place that right there at that intersection point. And as always, we've got to rotate that because it's looking down the x-axis. So now we can see that we have this this different structure in there. Let's just pull it up and look at it separately. Might be easier. So you can see we've got pipe bus on the high side of it. It's a 2.5 inch pipe bus. Excuse me, on the main bus is a 2.5 inch pipe bus. We're using some flat bar here for jumpers. They could be easier to be conductor. We're using an angle bus for the transfer bus. The advantage of transfer bus is you don't have all the expensive connectors. It's just 4 bolts and some holes. Somebody's got to make those holes, however. Then we come over on the low side. We come across from in between the bypass switch and the isolating switch to a structure over here, a T structure that has provisions for lightning arresters, and then here is where we would tap to go. We would place, probably as part of the line construction contract or work order, we would place your terminators here in the cable and make the connection up here to these terminals right here, or these connectors right here. So that's the underground exit bus, underground exit bay, And so that's what we're going to be using here, just for a little variety, and to show a few other items. Now, we need to make a connection to this bus, and I have this will be our last. We can call it jumper if we wish. It's not a conductor. It's not a wire jumper. It's bus jumper, and it's very similar to the riser connection we made before. So I actually called the program Riser 2 because it was the second one, but also because it's got two legs. We're going to come across here and then elbow up to this bus. So we can find that over here. It's this one right here. You can see where it's coming and elbowing up to the bus. Kind of looks like a J. And now we get the message that says, click OK, set layer to X bus or X conductor, and then press enter to proceed. So let's press OK to get rid of that. We need to come up here, and once again I forgot to set my layer. This is 2.5 inch bus, which is we can review that in a minute, and let's hit enter here and look at the ampacity on that. So we're coming from this side of this connector here. We're going to come from here, and in this case we want to make sure that we are perpendicular to that point, because we want to come straight out and then go straight up. So we'll use we'll type in PER to make sure we're perpendicular, and then we see right away that we've got a major faux pas in that we have come right up through that other jumper and right into that connector, and I think in the Wizard of Oz they said just ignore the guy behind the curtain. We'll come back and deal with that here in a minute. Let's go ahead and put the rest of our jumpers in. So let's go back up and click that, and then again let's make sure we're perpendicular to this bus, and then we can just hit enter, and again type in perpendicular. And now we've got our connections made to those. Before we go any further, let's fix our problem. So you may see here the solution is already been determined, and we're just going to move this structure 1 foot in the minus X direction here. Here's your minus X direction, and that will then offset that. So to do that, we're going to come over here and use the move excuse me, I said minus X, that's a minus Y direction. We're going to move in the Y axis. Now, normally when you click this, it will take the last object that was inserted and move it, but if we select this bay that we've already inserted and say move in Y axis, and it comes up and says distance to move selected objects in feet. So we're just going to tell it minus 1 foot. We want to go 1 foot in the minus Y direction, and say OK, and then you see it moved, and this connector that was hanging out there in space is now correctly connected. And let me cancel my selection, and now we can come in here and make a connection to this bus. So let's go back up to our connectors. So we're going to need a T connector for tube to tube, and this is a 2.5 inch tube. So we want to pick not node here, not intersection, but end. So we're going to go to end, pick the end, and wouldn't you know it, we got to rotate it. Then we can simply copy it, end. I knew I was going to do that. I'm down there amongst the down there in the weeds, as you might say. Actually, I don't think that jumper actually went to the bus. So let's cancel that. Let's come in here. We're going to just delete that. We want to delete both the line and the solid. So let's come back in and do that again. So let's say let's do this again too. Let's come back up here and put it back on the 2.5 inch aluminum bus. Come down here and hit our enter, and now we can come back and snap there, and then say perpendicular to let's make sure we get it perpendicular to this line right here. Okay. And so now we can do the easiest way to do this is just go in and just insert this one. If we can find the end of this bus that was not right, insert. And once again, we got this bus hidden amongst everything else. Let's do a cancel, insert, rotate. Okay. So now we've got this bay in connected. It's located correctly. Let's go back up here to the plan side. Now we need to add in our two other bays here. So let's go back to our structures. And if you remember, we were talking about, okay, this is the 2101 that we have in here now. We want to put the 2201, which is missing this column and this horizontal support. So I'm going to just insert this right on top of the other one. Do an insert. I'm inserting it at the insert point of the original one. And you see it goes in. Now we're going to rotate it in the Z-axis. Now this time we're going to use the move command. We're going to move in the Y-axis, and we're not going to select it because it's going to assume that the last thing we entered is it. And it needs a 15-foot base, so we're going to move it in 15 foot, and there we are. Now we could insert another one, rotate it, move it. I'm going to just use a simple AutoCAD command and say copy last, and then return, and I'm going to tell it to move it 0 in the x-axis, comma 15 feet in the y-axis, and I'm going to hit return twice, and it will copy it, another bay in there. So that's just using your raw AutoCAD commands there. So we now have not quite completed the station. Pay attention, George. So we've got to finish up these last two little spans of wire. The first thing we need is a connector. This will be a coupler connector from a 2.5 inch. Here we need to talk about this wire again. So let's bring up our design again. And this is an 182430. So we normally would think we would need something like at least 1500 amps capacity. The smallest conductor we can use is a double 750 to get us 1500 amps. And if this was a real design, I'd do that, but just for simplicity, I'm going to go down here and make it 1000 MCM. And let me go back up here and point out too, on our 2.5 inch conductor, our 2.5 inch bus, it has a 1600 amp ampacity, so it's plenty enough to carry our 182430. So that's why we drop down to 2.5 inch there on the low side. So let's go in here, and we need to go back to our connector. It's our coupler tube to cable. It's the in this case we're going to be using the 900 to 1250 to 2.5 inch 9 to 1200. Insert. There it is. Copy. And then over here on this side, this is where we need our old buddy, the terminal cable to flat, the 4/0 to 1000. That's the one we used before. Let's undo that. So we want to go to the node, insert. Then we'll rotate this twice, and then do a copy. And then we need to come back over here and insert this one. We could have copied over there and rotated, but I knew that was going to come in without having to rotate. Just that one. Do an undo. Did we get this one right? Yeah. Okay, so we're good. So now we're ready to do our jumpers. I'm not going to get caught in that problem again. I'm going to go up here to 1000 MCM. I'm going to come down here just my straight jumper. node to node. Hit enter to reissue the command. Hold on here. We've got two connectors here. Let's see which one of these is the wrong one. That looks like the wrong one there. I don't know how I did that. I guess I did a double pump. I mean, there's nothing you can do about bad operator. It'll make good software look cheap any day. So now there you go. We have all of our connections in, all of our cables, everything in that we could make this a full working substation. So we've got a well, no, we don't have everything in to make a full working substation. I mentioned earlier couplers. I notice I've got some couplers on here left over from a previous opportunity. I need to get those off because otherwise it will put couplers on top of couplers. I think I could probably make a simple change in the software and have it look to see if there are couplers already there, because quite often you come back and make some changes and you don't want to have to go delete all the couplers, so you can just re-add couplers. So let me just make a comment here. So couplers is a simple command, couplers. The sticks of pipe bus generally come in 10, 20, 30, and 40 foot lengths. 40 may be a premium length, and so more typically it might be 30. But for purpose of our little demo here, I'm going to limit it to 20 foot sticks because it'll give us just a little bit more to look at. So I'm going to come here, it says enter max pipe length, I'm going to put in 20. So it goes in and highlights every bus that gets one or more couplers. Now if we want to see the couplers, we can zoom in or whatever, but when the app runs, it makes a selection set of what just got put in. So we can do a select previous, and then you can see here it will show us all of the couplers that were put in. So so this would be a 20-foot pipe from here to here, and then the coupler would here, and then the remainder. So you can see all the couplers that are required in this. Actually, if you use a 40-foot pipe, you could do away with any of these couplers. But then my demo would be kind of wimpy. Okay, so beyond that, then the last thing we need to do, let me do a regen to get rid of all the highlighting, is you want to have end caps on all of your open bus ends, which it appears here I already have end caps on all of them. So let me first erase all the end caps. Excuse me, so I know what I'm doing. Okay, so now they're gone. So you want the end caps on the ends of all of your open bus, and the idea here is you want to keep the birds out, and if you can keep the birds out, then you can keep the varmints from climbing the structure to get to the birds, particularly snakes, who seem to have a knack for somehow stretching out across the tallest insulator in the substation and shortening it to ground. So so we're going to do end caps, and again the command is simply end caps. It will go through and again highlight all the bus segments that get end caps. Now we've got one problem we have here is in these assemblies, because they are assemblies and they're blocks. It can't actually go into that and put them. I have to assume that you included end caps when you built your assembly. So so at this point we've got end caps here, and again we can do a select and say previous, and it'll show us where all the end caps are. So we've got end caps certainly on all these open ends of the bus. We've got end caps here where it's open, where we've got the switch. We don't have an end cap over here because that's not an open end with that connector. We've even got end caps here where we came up and used a tube to flat connector, so we've got an open end right there. So you can again, you can see all of the end caps that are on here. And with that, we really have accounted for everything in the overhead that's necessary, and we can at this point create our bill of materials, which is simply done by going up here and clicking on bill of materials. So here we are. Now, of course, this will only include the overhead portion that we see here. Any underground conduit or ground mat, etc., would need to be accounted for separately. That is something that probably could easily be rolled into this, but at this point, actually the conduit, if you had conduit in there, it would pick up conduit. Ground mat, as long as everything, as long as they were all formatted as connectors and as wire or conductor, it would certainly pick them up. Okay, we're ready at this point to go up here and do our bill of material, and simply click on the bill of material icon, and the first thing you'll see is it pull up Excel and fill out the Excel spreadsheet, expand the columns. So now here we've got, you can see here all of our bus types have been totaled up here by type. Go down through here, pick up all of these connectors. Here's our tube to flat here, our 4/0 to 1000. Moving on down, you've got you can see your CTs and your VTs. We didn't even talk about the Hall of Fame luminaires through there. You probably saw those. There's our 295 TR295 insulators, and here's our major items with breakers and circuit switchers, and on down your structures, switches, and each structure also has integrated into it a footing, and that footing shows a typical size. The footing size needs to be determined by a structural engineer, and certainly is not a part of this package. But these are typical size footings that you could expect for these specific types of structures. And if you have some experience that tells you a typical depth, you could come over here and create a couple of cells over here that would break this out into its area, and then with the depth you could arrive at the volume of concrete, or at least an estimate of the volume of concrete, which then when you have your foundation contractor, when they come in with their bid, you'll have something that you can at least measure against the amount of concrete that they are proposing for the project. And in fact, that's the main reason for this. Most utilities don't go out and buy this material themselves. They usually go through a substation packager. However, it would be good that when that substation packager sends their bid in and they've got a bill of materials included, you can go down through there and check against your numbers, and if you see any that certainly are lower than the numbers you have here, that would be the time to question the supplier, because you get down to the end of the job and found out you're short 1 or 2 connectors, or some feet of bus that may take 6 weeks for delivery, or some of these connectors are actually cast on demand. You may find yourself with a serious delay in the completion of your substation. So that's for your bill of materials. let me just run through one quick app that you might that you probably should run before you do the bill of materials, just to check. And let's put this thing in our orthogonal view so we can see all of them. But you should this display bus will display all of those lines that I mentioned, the lines, polylines, and splines, etc., that go into the into determining the full length of bus. So you can see here, somebody's not connected this bus in over here, so we've got a problem here. But you can see all of the bus all of the these are all the lines that are on the X-bus layers, the various X-bus layers, and you can see all through here that they're all highlighted. So this is a good indication that you've got a good handle on the total amount of bus you need, except for this that's missing here. Yeah, well, I'm glad I'm not a consultant, because you'd be asking me to give back some money. So anyway, this is this application, and you've got to be real careful with this. In order to highlight this, it actually has to explode all of these assemblies here. So you don't want to just dump out of this. You want to go back through this, and it doesn't undo to put the assemblies back where they need to be. Just one other little item, if you're just interested. I've got a little routine here that will change all of the red bus to gray, and change all the copper bus to a brownish color, and darkens up the structures a little bit to give you a little more maybe realistic view of what that substation might actually look like when it's built. I like the red for the contrast, but this is nice to see, just to look at. So let's go back to our plan view, and let me just remind you that if you've got any comments or questions, you need to go to the 3DUtility.com website and go to the contacts page, and there fill out any comments, questions. Be glad to answer any questions you might have, and I'm sure that that's now showing down here whether I can see it or not. And with that, I appreciate your time, and you might check back. I'm thinking of a few other videos that may not address specifically the toolbox, but some of the commands in AutoCAD that make excellent use of this 3D design to complete your contract drawings for not contract, but bidding drawings for submission to your substation packager. So with that, thank you, and goodbye.